A uniform ladder rests in limiting equilibrium, with one end resting on a smooth vertical wall and the other on rough horizontal ground. We want to find the value of mu, the coefficient of friction between the ladder and the ground. Since we have a uniform ladder, the weight will act at the center of the ladder. There will be a reaction with the ground, which we'll call R. The friction must act in this direction, since if the ladder were going to slide, it would slide in this direction. There'll also be a normal contact force with the wall. We're in limiting equilibrium, so therefore the frictional force must be equal to mu R. If we consider horizontal forces, these must balance out since we're in equilibrium. Friction acts to the left and N to the right. It follows that N must be equal in magnitude to Fr. So N is going to be equal to mu times R, since we know the friction is equal to mu R. If we now consider vertical forces, these must also balance out. Vertical forces are R and mg, so R is equal to mg. Let's call this equation 2. Since we're in equilibrium, we also know that there must be no resultant turning effect. If we call this point A and take moments about it, the sum of the moments must be 0. R and Fr have no turning effect about A, since they act through the point. This angle here would be 30, and so if we resolve mg, we get mg times the sine of 30 in this direction, and of course there is a component down here, but it acts directly towards A, so has no turning effect. If we look at n, this angle must be 60, we have alternate angles, so the component in this direction would be n times the sine of 60. There's a component this way, but it too acts directly into A, and so has no turning effect. In order to take moments, let's call this length A and this length A. We know the weight acts at the midpoint of the ladder. Then the turning effect of the weight will be mg sine 30, the component perpendicular to the ladder, multiplied by the distance from A. For this force here, the turning effect will be equal to n times the sine of 60 degrees, multiplied by its distance from the ladder. The a's cancel, and this gives us that 2n times the sine of 60 degrees is equal to mg times the sine of 30 degrees. Let's call this equation 3. We have three simultaneous equations, which we need to solve to find mu. From number 2 we can see that R is equal to mg. We can use this in number 1, giving us that n is equal to mu times mg. If we look at equation 3, rearranging, we get n is equal to mg sine 30 divided by 2 times the sine of 60. Both of these expressions are for n, so mg sine 30 divided by 2 sine 60 must be equal to mu mg. The mg's cancel, and then we can calculate mu because it's equal to what's left. So mu is equal to sine 30 divided by 2 sine 60, and this comes to 0.289, correct to 3 significant figures.